So we saw what is static friction and kinetic friction, correct? Now let's try to demonstrate what it is using simple day-to-day life objects, okay? So what we have, see, we are just using stationary objects. Even you can do it at home, alright? See, what we have is, first we have a writing pad, okay? So you have one writing pad, nothing else, alright? Then what you have a scale, okay? Then you have a marker, and then you have this wonder tape. Okay, so we have these 4 items. See, these are all day-to-day life items. How static friction and kinetic friction we can demonstrate using these things. Okay, that's all, nothing else. Alright, pay attention. See, first what we have is, see, for any cardboard, if you have noticed, this is a smooth side and this is the rough side, correct? You have 2 sides. Now, first static friction. Now, what was static friction? Static friction was whenever the object is at rest, there is a friction force, correct? Because of the normal, right? Now what we are taking is, we are taking this cardboard as our surface, and these are the 3 objects what we are looking at, alright? Okay, now first what we will do is, see, I am taking this wonder tape and then I am keeping this wonder tape in the normal plane, okay? No forces applied on it, nothing. Now for this, there is a normal, see, normal actually acts in this direction, correct? Normal is acting in this direction, and between the surface and the object you have some friction constant or coefficient of static friction, that was mu s, okay? So that is mu s. Now let's say I want to move this, okay? Now if I move, see, if I give only a small amount of force, it might not move, okay? It might not move. Now if I give a little more force, see, now it's moving, right? Now it's moving. Now see, to actually demonstrate how the coefficient of friction changes with respect to 2 different bodies, what we'll do is, see, we'll do a simple experiment. So what we'll start is, we'll start with an inclined plane, okay? See, I have this wonder tape, so first I'll keep it at some angle, okay? Next I have a scale, I'll keep this also here. If you guys can see here, see, we have a scale and we have a wonder tape, okay? Now this is making some angle theta with the horizontal. Now I'll start increasing the angle theta, okay? See, it's increasing. Now which is starting move, see, the wonder tape started moving in the initial. Now see, after this, even after increasing, the scale is still here. See, now the scale moved. Now what can we conclude from the experiment here? The conclusion is very important. Now the static friction of these 2 objects depends on first 2 or 3 different things, okay? Firstly, if I am talking about, it depends on whether the surface is smooth or rough, okay? This is the first point. Second point, how much of area is in contact, that plays a very important part. See, for the wonder tape, it's only this much, right? Whereas for a scale, I have this whole rectangular surface. So area which is in contact with the surface, that also plays a very important part. Then comes, between the 2 objects, what is the coefficient of friction? Alright, so these are the 3 things how the static friction depends on. Now if you look at the graph, okay, if you look at the graph, see what you have. So since we have the coefficient of friction more compared to kinetic friction, see, as you can see, as this moves, now this is moving, coefficient of static friction is more compared to coefficient of kinetic friction. Understood, right? This sums up the whole kinetic and static friction. Now about the surface again, I'm starting with the rougher surface now, okay? Now here, see, the same object I'm taking, okay, and the same object I'm taking. See, now if I do this, guess which one will come, which one will slide first? Will it be the scale or will it be this tape? Guess. Okay, if you have an answer in your mind, just stick to it. We'll do an experiment and we'll see. Okay, now see, I'm inclining. the scale moved first. If you guys have thought that the wonder tape will move first because the same thing happened in the previous case, now what is the reason behind this? Why is the scale moving in the beginning? It should not happen, right? Technically what we did in the previous experiment. Why that happens is, see, if you have a scale and if you have this, now one very important point is, see, friction is more when the objects are close or when there is interlocking, correct? Right? If the objects are like this, easily it can move. This is what is happening between this surface and the scale. Whereas, see, if you look at the tape, see, this particular point, see, it's in the circular motion, correct? It's in, sorry, not motion, it's in circular shape. Now, the tape, whatever you have, one is like this, the next one is like this, next one, correct? Whereas the surface in this is horizontal. Basically, these tapes, if you look at this, see, one is this, one is like one like this, one like this, one. They're vertical. This is horizontal. What happens between these two surfaces? There is interlocking. One horizontal, one vertical. One horizontal, one vertical. There is interlocking. But that doesn't happen between the scale and this. That is the reason this moved later compared to that of scale. So can we come up with one more observation? That is, friction also depends on what type of material we are using. Correct? So 4 points we come across. First point was, so whenever you have any surface, it depends on the surface. It depends on the last point, whatever we did. Okay, we'll start with 1, 2, 3, 4 and all these things. So first it starts on this, the surface material, right? Then the angle of inclination, then coefficient of friction, whatever we had, and then what type of material we are using. Understood? So this sums up the whole static friction and kinetic friction.